Rational expressions, we once again are going to look at numeric fractions to figure out our method. So if we have the fraction 6 out of 20, and we are multiplying that times 5 out of 18. In order to multiply fractions, we multiply the numerators. So 6 times 5 would be 30, and 20 times 18 would be 360. However, if we want to have an answer in simplest form, we can cancel any factors ahead of time. So I recognize 20 is really 4 times 5. And I recognize that 18 is really 3 times 6. Now, if I look, I can cancel any numerator with any denominator. So I have a 6 here and a 6 here. Remember that division and multiplication are opposite or inverse operations. And I have a 5 here and a 5 here. So now, if I multiply, all that remain from my 6 and my 5 were 1, so 1 times 1 is 1, and 4 times 3 is 12. And I have an answer in simplest form. Now remember, before I had said that I would have 30 over 360. Most of us recognize that we could cancel a factor of 10 by crossing out the zeros, which would give me 3 over 36. Take out a factor of 3, and that would give me 1 over 12, which is exactly the answer that I got immediately by canceling factors before multiplying. So in order to have factors, I need to factor. So I look at my first problem, and I know that I want to factor every single polynomial in this problem. So I'm going to start with those that look easy. So this denominator, I know that factors of 6 that add up to 5 are x plus 3 and x plus 2. So that one is easy to factor. In the numerator above that, I see a common factor of 2x. Because that's not a trinomial, I'm not looking to split it into two binomials. But if I pull out a common factor of 2x, I have x plus 5 remaining. Alright, my other denominator. I see a common factor here of 3x. And I'm left with x plus 5. Now I have one polynomial remaining to factor, and it's the hardest one, of course. So I'm going to start out 2 sets of parentheses. I know the factors of 2 are 2 and 1, so 2x and x. Now I want to multiply the 2 times a 3, so plus 3. That gives me 6, and that gives me a plus 1 here, and I have it factored. Now I cancel any common factors. So here I see x plus 3, and here I see x plus 3. Here's an x plus 5, here's an x plus 5. Here's just an x, and here's just an x. And what am I left with? I'm left with a 2 in the numerator times 2x plus 1. And in the denominator, I'm left with a 3 times x plus 2. And I don't actually have to multiply these together. Alex won't make me multiply them together either. I'm done with the problem.